and we're going to take a tour of Galileo and infinity, and how Galileo enhanced our concept of infinity. He enhanced it by being a skeptic of infinity, but the thoughts that he had helped us to expand our notions of infinity that we have today. So I'm going to start with a poem written well after Galileo. By William Blake. To see a world in a grain of sand, and a heaven in a wildflower, hold infinity in the palm of your hand, and eternity in an hour. So this was a mystical idea, a concept that you could have the infinite in the finite. Now Galileo wasn't interested in very mystical ideas. He was much more of a rationalist, much more of what we would today call a skeptic. And so he was skeptical of the idea of infinity. It had to be careful, because in that time, to doubt infinity could be interpreted as doubting God. He had already run afoul of the church, so he was under house arrest. He couldn't really do science or astronomy anymore. So he returned to what he was originally trained to do, which was mathematics. He was a professor of mathematics, and he began to ponder mathematical questions. One of those was, could infinity exist? So he had to be very careful, so he did this as a thought experiment. Can I establish two values of infinity that should be unequal as being equal? For instance, if I have an infinite number of very large objects and then an infinite number of very small objects, would I have the same volume? If I did, then that's paradoxical. That cannot be, because you're saying that something that should be a larger volume or unequal volumes are in fact equal. So what he decided to do was discuss the points on a line, an infinite line, and then the points on a line segment. Both are infinite, but the points on a line should be, according to Galileo, there should be more points on an infinite line than on a line segment, and yet he showed that that is not the case. He categorically showed that you can in fact pair the points of a line, an infinite line, and of a finite line segment. And as you pair those points, you have then established an equal number. And yet, Galileo felt, or believed, or accepted a priori that that was an unreasonable suggestion, that there had to be more points on an infinite line, and that therefore infinity was not useful. So here we go. Here's what he did. Let's take this as a very large line segment. You have first, before we make it a line, you have an origin point, and then you have a semicircle. And you have rays going through this line segment such that you have an infinite number of rays such that they intersect every single point on the line segment, this red line segment. You'll notice, though, that they are also intersecting points on the semicircle. And in fact, this line segment is longer than the semicircle, which is a line segment, but it's one that's curved. And yet it would appear that the semicircle, in fact, has more, well, they're pairing points, right? So you have this point here paired to a point out here. You have another point paired to a point. So you have points being paired, but then you have points left over up here in the semicircle where you don't have rays intersecting this line segment. So you actually have more points seemingly on the semicircle than the line segment. Now if you extend the line segment to infinity and it becomes a line, then they would exactly pair. So you would have, simply by curving this line segment, you would have an exact pairing of points between the line segment and the line going to infinity. So to Galileo, once you show that you're able to do this, you don't really have infinity as a useful concept. And so for centuries after that, the analytical Western mind, following in the ways of Galileo, Newton, Descartes, the 18th century Enlightenment, they just threw infinity out as yet another construct of the past. In fact, when Berkeley pointed out that calculus relied on infinitesimal and the concept of infinity, they just came up with the idea of limits. As the limit goes to infinity, or as the limit goes to the infinitesimal, to just avoid the whole concept. But the artists, the poets, they held on. like William Blake. And particularly, they held on to the idea that the infinite is not just some construct out there, that it can actually fill the finite world. Now, just like Galileo ran afoul of the church, many of them also ran afoul of the church too. They were not what you would call system religious thinkers. But they inspired a lot of your poets, your artists, your and I mean this in the best sense, your madmen, like not only Blake, but Shelley and Byron and some of your favorites you've read in your English courses. And they continued to hold on to the idea of not just infinity, but other metaphysical concepts. Well, eventually Georg Cantor came and unified the thinking of Galileo, the very analytical thing, including, by the way, the idea of pairing numbers and pairing points, with some of the out-of-the-box mystical ideas of William Blake and the idea of seeing the infinite in the finite. And out of him came a lot of our modern notions of set theory, infinity, and mathematicians today do accept the idea of infinity. How he did it, how Cantor did it, by the way, was redefining infinity away from being a number to the idea of being the measure of a set. So infinity was not a number on the number line. It was the measure of the set of certain numbers. He also, by the way, discovered that there are actual unequal levels of infinity. So you have the infinity of the real numbers is a greater infinity than the rational numbers. So once he discovered that, infinity became a useful thing you could actually study, and its prestige was restored. The point is, Cantor did it by unifying the analytical ideas of Galileo with his own zaniness and craziness as a out-of-the-box thinker, a bit of a mystic in his own right. And so he took the rational, he took the mystical, he put it together, and he had the creative. CHistrue signing.